Right, so our first lesson is on series and sequence. We are using the Akiola Elective Maths book, chapter 15, Mark 1. That's the first video. So, series and sequence. So, a set of numbers that have a specific order. That's a series. That's a sequence. So, if we take numbers like this, for example, in here we have 7, 9, and 11. This forms a sequence because the numbers are separated by commas. If the numbers are separated by plus, right, a summation of all the numbers in the sequence forms a series. So 1 plus 3 plus 5 plus 7 plus 11 plus 9, plus 11. That forms a series. Good. And then today's we're done with sequence. So a set of numbers with a particular order is a sequence. So these numbers have a particular order. If you study them, the difference between the numbers is always 2. So between this one and this one is 2. This one and this one is 2. This one and the next is 2. So every term and its preceding element, there is a specific order, right? Then let's go to the types of. So we are done with sequence. We are done with series. Let's go to the types of sequence. Right, types of sequence. There are two types of sequence: arithmetic progression. This lesson we are going to use AP to represent arithmetic progression. So arithmetic progression is also known as linear sequence. They are the same terms. And then we have geometric progression. This lesson will be using GP, also known as the exponential sequence. Perfect. So we'll start with arithmetic progression. Arithmetical progression. Right. So in arithmetic progressions, right, reading from here, you can see reading from here. An arithmetic progression or linear sequence is a sequence in which any term differs from the preceding term by a constant called common difference. So there are some keywords. So any term, right, differs from the preceding by difference. Right, perfect. So there are these terms. Any term means that you take any series, right, or any sequence. So let's take 1, 3, 5, 7, 9, 11. This is our sequence. Any term means we can take this term, this term, this term, this term, this term, this term. So if you don't know what terms are, term represents any component of the sequence. So this is a term, 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 this is a term. And then when we want to identify them uniquely, we give them numbers, right? So this is the first term, the second term, this is the third term, and so forth and so on. So yes, when you take any term at all, so when we take, let's say here we take 9, which is our 1, 2, 3, 4, 5, our fifth term. its preceding term, which also means the term that comes before that term, is 7. The difference between 9 and 7 should be a constant. So let's see. When we take the last term here, it's 11. 11 minus its preceding is 2. 9 minus its preceding is 2. 7 minus its preceding is equal to 2. 5 minus its preceding is 2. Then 3 minus its preceding is equal to 2. So these are the constants, right? These are the constants. This is the constants they are talking about here. You can see constants here, right? The constants they are talking about is the fact that when you take any term minus its preceding term, preceding means the term that comes before that term is always 2, right? And that constant here, we call it the common difference. Here, the common difference is represented as D. So when you see D, it stands for the common difference. The first term, right, you see, is represented as A because A begins the alphabet. So A, B, C, A is the first term, so we use A. And then D is the common difference because of D stands for difference, right? Let's see. So let's now look at how we are going to represent our terms, right? So reading from here, for a linear sequence, the first term is denoted by A. So A is the first term, and the common difference is difference by D. The nth term is denoted by Un, right? What we mean by nth term is n stands for any integer. The integers, the first term 1, 2, 3, 4, 5 of these numbers, right? And it doesn't end, so it's infinite. So dot 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 like that. It's supposed to be 3. So when you see a sequence with these 3 dots at the end, it means that this sequence doesn't end, right? It is infinite. So this is an example of infinite sequence. Here, yeah, all these are examples of this because of the 3 dots makes it an infinite sequence. Because of the 3 dots here makes this series infinite. This one is finite because there are no 3 dots at the end, right? Get it? Perfect. So let's continue. Right. So UN represents the nth term. So if I want the first term, I'll just write my U and put my 1 here because it's the first. First is 1. My second term. So my second term I'll represent with U and then what 2 as my subscript. My third term will be equal to U subscript 3. Do you get it? So the 54th term 54th term would be U54. Get it? Perfect. So that is it for. So this also means that U of the first term, which is represented as U1, could also be represented as A, right? Perfect. So now let's go to a general formula for obtaining the terms of a linear sequence. When it comes to AP, what's the general formula? The general formula we use for an AP is UN is equal to n minus 1 d, right? UN is equal to a minus 1 d. Let me put this in the box. So take notice of the ones that I write in the red ink. This means that to find the nth term, the formula is given by the first term plus n, which is from here, minus 1 times the common difference. It is very simple. It's a very simple formula. So using this formula, let's write out the first 4 terms of an AP. Let's see. Let me clean this side off. So let's see, first four terms of an arithmetic progression. So the first term, u of 1, will be a, right? Because we said that it's a. But if you are using the full formula, it could be a plus n minus 1 d, right? But we know that n minus 1, where n is 1, because n here was 1. You see n from here, we want the first term, so we replace with 1. Then 1 here makes it 0, because 1 minus 1 will be 0. So 0 times any number is 0. In the end, you are going to get just a. So the first term is a. Let's see the second term. U of 2 is equal to a plus 2 minus 1, right? D. We don't know the common difference. So it will be a plus what? D, because this is 1. And then u of 3 is also a plus 2d. If you do it, you see the u of 4 will be a plus 3d. So always it's just going to be subtracting 1 from here and then multiplying it by the d, right? So if it's 4, it's going to be 3. If it's 3, it's going to be 2. If it's 2, it's going to be 1. If it's 1, it's going to be 0. Plus the a. So perfect. These are the first four terms of an arithmetic progression. See the d. How do we get d? The common difference. Calculate d. It's always a term, right? Its preceding term. So if the term is the fifth term, its preceding term is the term that comes before 4, right? So before the fifth term, which becomes the fourth term, so it becomes u of 4. So it's always the one in front is always one higher than the one here. That's why in the formula we use d is equal to u of n, right, minus n minus 1. You see, so n minus 1 and n, we always make sure that this one is bigger than this one by just 1. It's greater than it by 1. So let's write the formula for d2. D is equal to, so let's take note of these formulas. So let's take our first question. Our first question from example 1 here, right? Example 1 says that find the 11th term of a linear sequence of the form this. So we've been given the term. We've been given the sequence 4, 9, 14. 19, right? And then we want to find the 11th term. It means that when we continue, this is the first term, the second term, the third term, the fourth term, fifth term, sixth term, seventh term. We'll get to the 11th term. But we cannot add the common difference. See, from here we can see that the common difference is 5. Because when you subtract, you always get 5. But we cannot add, so we use this formula. Formula we state here because this is an AP. So first, to use, let's write the formula. U of n is equal to a plus n minus 1d. So in the formula, we need a, we need n, and then we need d. What is n? We are looking for the 11th term, right? So u of 11. The 11th term is equal to a plus 11 minus 1d, which is going to be a plus 10d. So that's our 11th term. All we need to get is a and then d. So what's a? A is the first term. And then we can see it from the sequence. The first term from here was 4. So a is 4. So a is 4 plus, let's write it, a is equal to 4. What of d? D is equal to, take any two terms and subtract them. So we take, let's say, maybe I want to use the first and the second. So u of 2 minus u of 1. Please note the proceed. It shouldn't be 1 minus 2, but it should be 2 minus 1. because it's a term and its preceding. So we'll choose this and its preceding. So that's 9 minus 4, giving us 5. So 10 into bracket 5. So A is 4, sorry, A is 4. So we have 4 plus 50, giving us 54. So the answer is 54. Right, so therefore the 11th term of this sequence is 54.